Hey everybody, welcome to our Friday lunchtime lunch and learn. So first of all, let's just take a look at what we're doing. So I'm going to go ahead and select the job folder. Basically the first job folder is Op1, second job folder is Op2, and I'll run a stock simulation just so we can get an idea of what's going on here. And that was a little bit too fast, so let's try that again. Slow it down a little bit. Facing off the top of the part. Rough turning the OD on side 1. Come in and do a side groove. Now we're drilling side holes around the outside of the part. We came in there with an 1 1/8 spade drill, and then we are now boring the inside diameter. (2D) adaptive cut, running out these or roughing out the slots around the outside of the part, and come back with a finish cut. And drills went kind of fast there, but we drilled into the face, drilled and reamed, and threaded the front side, and then as you can see we're off working on the back side. So let's see how far we can get on the front side, and if we've got some time left over we can take a look at the back side. Alright, so there's the end of our stock simulation. Click OK here, and let's just take a look at how we have this part set up. So I'm going to basically recreate the setup and start from scratch. So the first thing we want to do to machine a lathe part, as on the mill side, create a new job folder or a new job setup. Now under this first drop-down menu, we can set the type to turning. As in milling, the first thing we want to do is define the model that we're going to machine. Actually, I'm sorry, I need to take a step back here. Let's cancel out of there for a second, because what I really wanted to do first, as this is a lathe part, it has a lot of milled components on it. So what we're going to do is create a spun profile. So this is going to allow us to define a round part that would have typical lathe geometry on it. So I'm going to create a spun profile. I'm going to select a rotary axis. I'm going to select the model and click OK. And if we look back here, what SolidWorks has done is actually created a spun profile of the part. So it's basically turned it into a lathe part and removed all of the milling features. And I have 2 of those bodies now since I've done this spun profile twice. Okay, so now let's go ahead and get started. Click on the job folder. Turn this into a turning part, and the model is populated with both models. So what I'm going to do is deselect that, and then I can just pick the spun profile. Now under stock, we're going to start with a cylindrical part, and then we need to pick a cylindrical face to define the orientation of the stock. We're going to, instead of just adding values, we're going to use a stock radius. So 4-inch bar stocks seem to be pretty close to me for what we're going to need. So I'll go ahead and type in a 2-inch radius. I'm going to type a home position of 0.5. So this is the first Z position as the tools after a tool change when the turret rotates and it rapids back towards the part. We're going to get a home position. So 0.5 is going to be the home position. And my jaws are sitting out in space here. I'm not sure if I'm doing something. Okay. I still have not defined my work coordinate system. That's the problem. So for my work coordinate system, up until now on all the mill classes, I've been showing you to pick a work coordinate system or to create a work coordinate system in SolidWorks. In this case, I'm going to create a work coordinate system using model and orientation. Yeah, and I was just checking my questions page at Payne. Looks like Pete was pointing that out to me, saying, hey, show us how to set up that. So what we're going to do here, using model and orientation, and we have the selection box ready to go, and what we're going to do is pick the face of this part. So we've picked a face, and that has automatically set our part orientation, so you can see that the Z-axis in the positive direction is aligned with the center line of the part and pointing out in the positive direction towards the tool turret. And that should really do it. We're going to make this part in 2-ops, so it's being held in the jaws. And I might take that up to maybe 1 inch, just kind of make sure I'm clamping those pretty good. Just gives you kind of a quick view of how your part's going to look. And I think that'll do it for job setup. Okay. First thing we're going to do is just face off the part. Go ahead and select the CNMG 042 turning and facing tool. And really on the facing toolpath, you just need to click OK because we've got our stock defined, we've got our model defined, so it knows what to do. I'll give it a maximum spindle speed of 3,500 and click OK. Again, my default behavior in HSMWorks is to just click OK and see what the toolpath does. It usually gets me pretty close the first time, and if it doesn't, I can always adjust things. Okay, we have a facing toolpath. And if you'll notice this little dog leg here, when I set the home position to 0.5, this is what I meant. So this home position is basically half an inch off of the face of the part. Okay, the next thing we're going to do is to turn the outside diameter. Click on Turning Profile. Going to pick a different OD turning tool. Click on the Model tab. Now, the model's already defined, but we don't want to cut the entire part. So what we're going to do is set a confinement, basically a boundary. Stay within this boundary. So I'm going to pick that front face and that back face. And if you see, this almost looks like a threading geometry up here in the top. It kind of shows you where we've constrained the cut to. Now, for the model, we've got a couple of models, so let's go ahead and make sure we're choosing the spun profile. So I'm going to expand the SolidWorks history tree and just define that revolved model just to make sure everything's good. And let's click OK and see what we get. So that looks pretty good. It's turning a little bit past the edge of the part, and it's got that, I think it's a 55-degree angle on this insert, so it's allowing the insert to kind of dig in the back. I don't really want it to do that, so let's go back here, right mouse click and edit the cut, and I'm going to take this confinement down to 0. So it just says, basically right now it's allowing it, or actually forcing it to overcut in the Z- direction. It's going past the edge of that, the face of that part that I defined by 0.118. So let's put that back to 0, and that's a little bit more like what I want to see. So we've got the part faced, we've got it turned. So the next thing we're going to do here is to machine this groove. So I'm going to pick turning, single groove. On the first tab, I'm going to pick our grooving tool. For the geometry tab, I'm going to click in the selection box. I'm going to pick that far face of the groove. Now if you notice, it looks like the tool has actually gone a little bit beyond the tool. That's because my alignment needs to be set. So I'm going to set the alignment to the front of the tool. And then on the heights tab, if I was to leave this set to model bottom, it would actually machine that groove all the way through the part. So what we're going to do there is pick a selection for the bottom of the cut, and now we're going to pick that face. And you can see this blue cylindrical kind of gives you an idea of the depth of your cut. So all of that looks pretty good. Let's click OK and simulate and see what we have. Okay, I like that. Just take a moment. Let me just check our questions pane quickly. And this is going to be a little bit tricky. I'm working on one monitor today, so it makes it a little bit difficult to read my questions. So I'm actually going to undock that for a second. Can you keep the rougher out of the groove? I'm not sure about that. Let's keep that question for a moment, and maybe I'll get CJ online here in a minute. He's a little bit more experienced than I am on the lathe stuff, and see if he's got, if he can help us with that.
Yes.
Thanks, CJ. Short answer is yes. So how would we do that?
There's a check mark in the Passes tab called Allow Grooving. You would just uncheck that.
Okay, let's go ahead and do that. Take a quick look there. So that would have been in this turning face. Right mouse click, edit, and is that in the Passes tab? Allow grooving. Uncheck that box. Click OK, and that keeps it out of the groove. Excellent. Okay. And then let's see, we've got another question. This can wait to the end, but is there a library of tools that we can download? Well, there are certainly are sample tools within the software, and then CJ actually did all the work on this file. I wonder if CJ would mind if we were to make this library accessible to our viewers today. What do you think, CJ?
Yeah, that's possible.
Okay, perfect. So anybody who would like this tool library, give me a shout, send me an email, derek@p9cam.com, and we'll get this tool library out to you. Okay, hopefully I can find this question pane again later. I'm just going to kind of drag it down here. Okay, what are we doing next? Let's see. We are going to drill the side holes. So what I'm going to do here is go back to the SolidWorks tab and make our actual part visible. And take a quick look at what we had going on here. Okay. So we're going to drill first that slide hole, and then we're going to add a circular pattern to drill that hole around the diameter. So drilling, drill. I'm going to pick a 0.1285 diameter drill, select that tool. Click on the Geometry tab. Now the first thing we want to do here is to set our tool orientation. So I'm going to check the box. And this is going to, basically we're telling it that we're working in a different orientation than we were on the lathe because the Z-axis now needs to flip out to the side of the part. I don't remember which hole we picked, but I don't really think it matters. So I'm going to pick a cylindrical face to set the tool orientation. And I see the Z-axis is pointing down, so I'm going to reverse that axis so that the Z-axis is now pointing up. And after I've set the tool orientation, I'm going to go into the hole selection dialog box and go ahead and pick that same cylindrical face. Hopefully software is going to let me do that. Sometimes it does get a bit funny when we're on a go-to meeting. Try clicking out of there for a minute and back in.
I know what the problem is. So that needs to be the model chosen in the job selection.
Because I have the revolve selected instead of the actual model. Got it. Thanks for noticing that, CJ. Okay. So I'm just going to cancel out of there for a second. I'm going to edit the job. And sometimes we're going to be picking geometry as we're moving through this part, and sometimes we're just going from the model itself. And so the mistake I made there was to pick the spun profile as the actual model. So I'm going to clear that, and I'm going to actually pick the part itself. Okay. And I'll need to regenerate those tool paths, but I think everything will still stay pretty good. Okay, it looks like everything's stuck with us there. Okay, let's try that again. As I always remind you folks, this is live TV. Anything can go wrong. Back to our drilling tab. Pick a drill. Geometry tab. Tool orientation. Now we'll go into the selection box and pick the cylindrical face. And as you see, we're still needing to reverse that Z-axis. So click that. Check on our heights tab. We don't really need to drill through so far. We definitely do want the drill tip to drill through the bottom of the hole. Passes tab. This could be deep drilling. That'll be fine, and we'll get some PEC action. Okay, that looks good. Now what we're going to do is complete those holes around the outside of the part. So what we're going to do is we're going to select that drill operation, and then we're going to click on pattern. We are going to create a circular pattern. You'll notice this is SolidWorks functionality. For a selection, we need to pick a face, basically an axis of rotation. So we're going to pick a cylindrical face, and we're going to have 16 instances of this hole. So each hole is spaced 22.5 degrees apart. Click OK. Highlight the folder, and we'll simulate the drill. Okay. All that looks good. Now, as we created a pattern, the software automatically creates a new folder. This folder is the pattern, and this operation is the operation that's being patterned. You'll notice that folder number 6 is bolded now, which means it's the active folder. If I create any other operations now, they will also be part of this pattern folder, and they will be repeated in a pattern. So what I need to do is go back out to my actual job folder where we've done our job setup, right mouse click, and say make default folder. So whichever folder is bolded, that is where the toolpath will be applied. So just be aware of that. Okay, the next thing we're going to do is rough this inside diameter here. So we're going to go straight in there with an 1 1/8" spade drill. So drilling. Click on my tool library. Pick a drill. Click on my geometry tab. Now you'll see that the tool orientation is still active. We're now working back in the Z direction for the lathe part. So let's uncheck tool orientation. You'll see your Z axis is now pointing straight out. Our hole selection tab is highlighted, so we'll pick the face that we want to drill. Go into the heights tab. In this case, drilling through the hole bottom, going an extra 0.2 is probably a good idea. We're going to need to get in there with a boring tool momentarily, so we'll accept all of that. And nice short pecs there. That looks like we're good to go. Okay, so we've roughed out the inside diameter. Now, next thing we're going to do is apply a boring tool path. Turning profile. I'm going to pick a boring bar from my tool library. We're going to check the box that says machine inside. So now we've defined this as an ID operation. Okay. Again, it's looking at the whole model, so we're going to select a confinement here in the geometry selection, and we're just going to pick that internal face. So it's just going to confine the tool to that area of the geometry. Right now it's set to drill past the back face by about 0.118. You'll remember we had the drill going about 0.2 beyond the back face, so 0.118 is probably a little heavy, but I definitely want to go a little bit past, so maybe at least enough to get past the radius on the insert of the boring tool. So let's go about 40 thou past. Now on boring, this is where it gets a little bit tricky on the heights tab, and in general in HSMWorks the heights tab was probably what was most difficult for me to learn, to get my head around. The software is pretty easy once you know how to use it, but the heights tab takes a little bit of thought, and especially on boring toolpaths, this is something I believe this is actually being addressed, but it's a little bit tricky. So let's kind of work out how we're going to set the heights for an ID boring tool. And we're going to really kind of start from the bottom here and work backwards. So the bottom of the cut, which is, depth of cut, is the way you want to think about this particular selection, is going to be where the cut finishes. So we're going to select that cylindrical face. It's a little bit counterintuitive because bottom, you might think it's coming, smaller and smaller and smaller. In this case, because we're working outwards, the actual face that we're going to machine is the bottom of the cut. Now, we pre-drilled this with an 1.1/8" diameter drill. So where we want to start cutting with the boring bar needs to be set. So what we're going to do is we're going to set an absolute value. And right now it's set to absolute from the origin, which is the center line of the part. We've already got a hole in there with our boring bar. And that boring bar was 1.1/8. I'm sorry, the drill was 1.1/8 diameter. So we're going to set our height to the radius of the drill that we used. So that value is going to be 0.5625. Now, we need to set our retract value, and I'm going to set that from minus 0.01 from what we defined as the top. Okay, so this was supposed to be 0.5625. Okay, so that it retracts 0.01 below 0.5625. And then the clearance height we're going to set just from the retract height, which is what we've just defined, and we'll just say minus 0.01 from there. So I realize this is a little bit complicated and it might take a while to work through. It certainly did for me. But give us a call when you're working on a lathe part and you're struggling with this, and we'll help you get through it. Passes tab, I'm just going to accept my defaults, and let's see what we get. So we'll click OK, and we have an ID boring toolpath. So we're good to go there. Take a minute to just do a quick simulation. And there we go. Okay. Let's take a minute here. We're just a little bit over halfway through this presentation, and as I thought, it is taking a while to program the part. If you've got any questions, go ahead and ask them now, and we'll take a break for just a moment. Okay, looks like we're doing pretty good. So the next thing we're going to do here is to machine one of these slots. So again, this is going to be a live tooling operation on the face. What we're going to do is we're going to rough them out, and then we're going to finish them out. So I'm going to pick a 2D milling, 2D adaptive cut. I'm going to select a 5/8 diameter flat end mill. On the Geometry tab, this selection is a little bit tricky. So what we're going to do, we want to pick in this area here. I'm going to uncheck Propagate Along Z so that I can just kind of contain where this toolpath or where this chain is going to be applied. And we get my direction right. And that looks pretty good. So that's the contour cut that we're going to apply with the 2D adaptive cut. And we also need to pick the stock contour, which is basically telling it where the stock is going to need to disappear from, which is this area here. On the Heights tab, let's see, for the top of the cut where it begins cutting, it's already defaulting to that face there, which is good. And then on the bottom of the cut, it's defaulting to from contour, which is where we define the contour, so that also looks pretty good. And let's just accept the defaults and see what we get here. So this is a pretty good looking toolpath. You'll see we're taking this in one depth of cut with a 5/8 end mill. It's pretty deep, but we have a shallow step over. So typical high-speed machining toolpath, which is what 2D adaptive is, using as much of the flute length as we can. And this is really where HSM started. HSM stands for high-speed machining, and the original toolpaths in the product line were the adaptive clearing toolpath. So fantastic toolpath, great way to remove material. Not a lot of load on the tool there, even though it's cutting a pretty deep slot all in one shot. Now we're going to follow that up. And so the other thing I should have pointed out here in this cut, the adaptive cuts will always default to leaving stock. They are roughing toolpaths. They'll give you a very good efficient roughing toolpath, but not necessarily a very good surface finish because they're designed for roughing. So we'll leave stock with that. And then we'll follow up with a 2D toolpath just to finish off that sidewall. So 2D contour, defaulting to the same tool. Pick the geometry in the same way. You notice I'm zooming up there. The first pick, whenever you pick a chain, defines direction as well as the chain that you want to cut. I'm not sure that I don't think we need to define a stock contour for this. Let's check our heights tab. Probably it's all pretty intelligent, defaulting to the right things. Let's just click OK. And we have a nice 2D contour toolpath just to finish off that sidewall. So now we're going to want to repeat that pattern around the outside. So again, I'm going to Control select the two operations that we're going to pattern. Click on the pattern icon. It's a circular pattern. We're going to define an axis of rotation. We need to define how many instances there are. In this case, there are 6 instances around the part. Click OK. And we see we've nicely patterned those 2 toolpaths around the part. Again, this folder is now bolded, meaning that it's the default folder. Any new operations that I were to program right now would automatically be patterned. So I'm going to go back to my job folder, right mouse click, make default folder. We are getting a little bit of excess noise there. Not sure who that is, so I'll mute the guys. Just send me a text, whoever needs to be unmuted, and we'll get you off of there. Okay, back into the job. So we have the pattern. So the next thing for us to do is to drill and ream these holes in the face of the part. Go back to drilling. Pick a 302 diameter drill. In this case, we're coming in from the face, so what we can do, we won't need to pattern this. We can just click select same diameter, and that will automatically populate all the other holes that are of the same diameter. Again, just, well, actually, we've got a reamer following this, so I think I will let that drill through a little bit deeper. So we'll go 200 thousandths past the bottom of the hole, plus the drill tip, and deep drilling full retract. That pet could probably be a little bit deeper. And we'll simulate that and see what we have going there. Okay, all that looks good, and we can just quickly Control D to duplicate that cut. That's one I learned from Tim, who's online with us today, and I like that. It's a lot quicker than copy and paste. I'm going to edit that toolpath. Click on my tool library and pick the 0.3115 diameter reamer. Nothing to change on the geometry tab. On the depth tab, I don't want to go through by 0.2. I'll just go through by maybe 0.1, and that leaves a little bit room down there for some chips to get out of there. And this could just be I think drilling in, wrap it out will be fine. Click OK there. So we've got our reamed hole. Okay, and we're in pretty good shape. So the last thing we need to do from this side is to do the threading on this OD, which we didn't really talk about. So let's see what we have here. So we've got a 2.375 diameter journal here. It's been modeled to be a couple thousandths undersized by the look of it. So the diameter is 2.373, which makes sense. And I believe it's 16 threads per inch. So let's apply the threading. Let's go turning thread. Pick threading tool. On the geometry tab, we're defaulting to 0.1 and 0.1. So basically the threading tool will start in the Z positive direction, 0.1, away from the part, and we'll cut past the end of the thread by 0.1. So that should be good. Our threading selection box is selected or is ready for selection. Color blue means it's ready to select geometry. So we just click the outside diameter of the thread. When you are threading, you're going to want to have your machinery's handbook handy, because you are going to need to know a few things. So in this case, the thread depth has been predefined as 0.037. We are taking 5 passes, and then the thread pitch is 0.0625, so that's 16 threads per inch. And we will click OK, and there are our threads. So we're looking like we're in pretty good shape there. We'll simulate that. Okay, we're good to go. Okay, Hunter having some fun with us over there on the questions pane. So now's a good chance, guys, if you would like to ask any questions. This is probably about as far as we're going to be able to get. We've got a few minutes left for questions, if we have any. Another quiet group today. Plenty of people out there, but either I'm just showing you this perfectly and you don't have any questions, or it's going right over everybody's head. So I'm not sure where we are on this, but I'll click a stock simulation, and we'll let this run out a little bit, And if you do have questions, now's your time.
Hey Derek, this is Tim. If you want, I have a picture of the hubs that CJ actually machined.
Oh, okay.
Send it over.
Cool. So let's go to your screen, and before I do, something look funny to you guys out there? Do I have too many holes on this, or is that just my imagination? I guess there is that many holes. Okay. All right, Tim. Somehow you're logged in here twice, so let's try this. So I'm going to go Tim Paul, panelist, make you the presenter, and let's see. I'll tell you when your screen pops up. There we go. Wow, pretty sweet.
Yeah. So CJ's here, but this is a hub that he made for this. I believe it was his SAE team. Is that right, CJ? Maybe CJ's not.
Yeah, I had CJ
from the ground up over here.
Yeah. So it's pretty cool parts. They look a lot better in person than they do on a graphic on your screen.
Mm-hmm.
But it's always nice to see the difference between a graphic on your screen and the real part. So thought some people might appreciate that.
Yeah, thanks for sharing there. And I don't know if you have any comments there, CJ. What was the application for this part?
So this is actually a hub for one of the wheel centers. There's lots of parts that go into the hub. So there's the hub, there's the spider for the floating brake rotor, and that goes all into an upright. So this is a fully engineered part. This isn't something that's just thrown together. In fact, one of the tolerances on the back end of the part is plus or minus 0.3 for the bearing pit. So there's a lot going on in this part. It's a real part, but it makes a good demo.
Yeah, it's fantastic. Well, we definitely appreciate you sharing that with us, and especially having made the part so we can see that the program actually works. What machine are we looking at right now?
This is a DS30 SSY, so it's Haas's dual spindle machine with Y-axis.
Nice. So when you programmed this, did you do the stock transfer and program the backside of the part in the second spindle?
Unfortunately, I didn't, because the machine was on a demo floor, not in an HFO, right?
Okay.
So they had a collet chuck on the sub spindle, so I didn't have any collet chucks handy with the right size.
Right. Okay, that makes sense.
If there was a chuck, I would have been able to, but.
Mm-hmm. Yeah, exactly. So work holding, as always, is part of it too, right? Well, great. If I don't see any questions coming in, and we're getting to the end of our hour, so if anyone has a question, let's just cover it now. If not, I think we'll sign off here.
Yeah, sounds good. Great job, Derek.
All right. Thank you. All right, everybody. So I think what we'll do is we'll plan a future webinar, and why don't we think about how we would do that in a second spindle, and maybe we can program the backside on the next one. So appreciate your time, everybody, especially CJ for making this part and the program and allowing us to use it. Tim coming in and helping out as always. Appreciate everybody's time out there. Realize your time is valuable, so when you spend an hour with us, we do really appreciate it. Check your email, folks. We will be releasing the May schedule for these Friday Lunch and Learn webinars. I think we're going to try and move into some inventor topics for the next month. We've been on SolidWorks throughout April. So watch your email. Thank you, everybody, and we'll see you next time.